Okay, first question. In this diagram below, we are given that line M is parallel to line N, and we need to find angles. And angles as marked, we need to find the angle X here. Okay, there are many ways we can solve this problem. So method one, we can. Okay, so note here, line M is parallel to line N, right? So if I make a line here that is parallel to line M and passes through line A, for example, let's call it line L. Can make M parallel to L, right? And because M is parallel to N, then L must be parallel to N as well, right? Okay, so because line M is parallel to line M, therefore, let's call this angle here alpha. Alpha is 35 degrees, right? Because 35 degrees here and alpha here are alternate interior angles, right? So they must be congruent. And also because L is parallel to N, then we have, let's call this angle here beta. Beta must be 40 degrees, right? Because beta and 40 degrees here are also alternate interior angles. And therefore, X equals alpha plus beta, which is 35 degrees plus 40 degrees, which is 75 degrees, right? Okay, so this is method one. Okay, any questions?
No.
Okay, of course, there is another way we can do it. So let me copy the graph here. Okay, this is line M. And this is line N. And we have an angle here. Point A, B, C. Okay, we know this angle here is 40 degrees, and this angle here is 35 degrees. Okay, let's consider method two, because we have already learned the properties of triangles, right? We can just extend the segment CA, and this line crosses with line M at this new point. Let's call it D. Okay, then we can consider the triangle ABD, right? Because M parallel to N, therefore we have this angle here, which is ADB equals 40 degrees, right? Because they are alternate interior angles. And in triangle ABD, we know that this angle here, angle DAB, is 180 degrees minus angle ADB, then minus angle ABD, right? Which is 180 degrees minus 40 degrees minus 35 degrees, which is 105 degrees, right? Therefore, X equals 100 degrees minus angle DAB, which is 180 degrees minus 105 degrees, which is 75 degrees, right? So you can choose either method to solve this question. Okay. Any questions?
No.
Right. If you have no questions, let's have a look at the next one. Okay, question 2. In the diagram below, the angles are as marked. Find value of x here. Okay, again, we can make a new line here. Let's call it HG. That is parallel to line AB. And pass point G, right? And because we have line AB parallel to line DE, therefore we have line GH also parallel to line DE, right? Therefore, let's call this angle alpha and this angle here beta. Therefore, we know x plus alpha equals 180 degrees because they are same side interior angles, right? If there are two parallel lines, then the same side interior angles, the sum of them is 180 degrees. Also, beta plus 110 degrees is 180 degrees as well, right? They follow me?
Yeah.
Therefore, we know the value of beta. Beta is 70 degrees. And x is 180 degrees minus alpha, right? And because alpha plus beta equals 180 degrees, because this is the vertical angle of this angle here. So, sorry, it's 140, not 180, 140 degrees, right? Therefore, we have alpha equals 140 degrees minus beta, which is 70 degrees, right? Therefore, we can put the 70 degrees into here. Therefore, x equals 180 degrees minus alpha, which is 70 degrees. Then x is 110 degrees. Okay, have a look at this question and let me know if you finish.
Okay.
All right, let's have a look at the next one. All right, in this diagram, we have a pair of parallel lines here, right? Line AB is parallel to line EF. Then probably we can use some congruent angles. So let's say because line AB is parallel to line EF. Remember that our task is to find our x here. Because these two lines are parallel, so this angle here and this angle here are alternate interior angles, right? Alternate interior angles are congruent. Therefore, angle BAE equals 4x minus 10 degrees. Can you follow me?
Yeah.
Okay, then let's consider the straight angle here. Apparently, let's mark it. This angle is 4x minus 10 degrees. If you consider this straight angle, then we have x plus 10 degrees, then plus this angle here, which is 4x minus 10 degrees. The sum of this 1, 2, 3 angles should equal 180 degrees, right? Because sum of the three angles is just a straight angle. Therefore, we have an equation and only one unknown quantity. It is probably possible to solve the value of x here. Then we have, let's simplify this, 6x, then plus 10, then minus 10, cancels with each other. So 6x equals 180 degrees, right? Which gives us x is 30 degrees. Okay, have a look at this question and let me know if you finished.
Okay.
All right, in your solution, I have found that you have used the wrong angle, right? You use this angle, but this angle is not the alternate interior angle of this angle.
Yeah.
Okay. All right, let's see the next one. Is it possible for two exterior angles of a triangle to be supplementary? Why or why not? Okay, so let's draw a triangle first to illustrate this problem properly. So suppose we have a triangle here. It's vertex A, B, and C. Then let's call this angle here alpha, this angle here beta, and this angle here gamma, and this angle here theta. So let us suppose sum of alpha and beta equals 180 degrees. Let's suppose this is possible and see what will happen. Then, because alpha plus beta equals 180 degrees, then angle B plus theta plus gamma plus angle B, because alpha equals the sum of the two remote angles, right? So basically this is alpha. And beta also equals the sum of the two remote interior angles, which is gamma and B, right? So this is beta. Then if alpha plus beta equals 180 degrees, then we have angle B plus angle theta plus angle gamma plus angle B equals 180 degrees, right? Because in triangle ABC, we have the sum of the three interior angles is 180 degrees, right? That means angle B plus gamma plus theta equals 180 degrees. Therefore, if we consider this equation and this equation, let's call this 1 and 2. Equation 1 and equation 2 gives us, actually, we can use equation 1 minus equation 2, right? This will give us angle beta equals 0. This cannot happen, right? Because angle beta is an interior angle of a triangle. Any interior angle in a triangle cannot be 0. So that contradicts with the assumption here, right? Let's say this is contradictory with the fact that angle B must be a positive number. Angle B must be greater than 0 degrees. Therefore, our assumption, let's call this asterisk. Therefore, assumption asterisk is not correct, is wrong. And therefore, alpha plus beta cannot be 0 degrees. Cannot be 180 degrees. Otherwise, we'll find a contradiction. Understand?
Yeah.
Right, let me, please have a look at this question and let me know if you finish.
Okay.
All right, let's have a look at the next one. Okay, it is known that one angle of a triangle is 20 degrees. If the largest angle of a triangle has 6 times the measure of the smallest, what are the angles of the triangle? All right, so basically we have a triangle and one of the angle is 20 degrees. Let's say this is 20 degrees. And the other two angles are unknown, right? So we can just call them X and Y, right? So we have 3 angles, 20 degrees, X and Y. And we also know that the largest angle of the triangle has 6 times the measure of the smallest. What are the angles of this triangle? Okay, so let me ask you a question. Which one of these 3 angles is the smallest? Can you determine that? From the given information, can you determine which one is the smallest?
X.
It's not Y, it's X. Well,
I don't know.
well, intuitively, it's not very easy to see which one is smallest based on the given information here, right? If you don't know which one is the smallest, you must discuss, right? Remember, we have talked about this similar question a lot of times. If you can't decide which one is the smallest, you can just discuss 2 cases. First, if 20 degrees is the smallest, this is possible, right? Can you follow me? Okay, if 20 degree is the smallest, then what will happen? Then we know that the largest is 6 times the measure of the smallest. Then the largest is 20 degrees times 6, which is 120 degrees, right? And we know one angle is 20 degrees, second angle is 120 degrees, then the other angle, or the third angle, is 180 degrees minus 20 degrees minus 120 degrees, which is 40 degrees, right? Then you need to check whether this assumption is possible. So in this case, 20 degrees, 120 degrees, and 40 degrees, smallest angle is indeed 20 degrees, right? So this is possible. First case is possible. Therefore, in the first case, the angles are 20 degrees, 40 degrees, and 120 degrees, right? But remember that we can't easily decide 20 degrees is the smallest. There is another possibility, which state that if 20 degrees is not the smallest, is not the smallest. You follow me?
Yeah.
Okay, if 20 degrees is not smallest, then either x or y is the smallest, right? Let's suppose x is the smallest, or y, it doesn't matter. Let us suppose x is the smallest. Right, then what will happen? Then the largest angle here, largest angle is 6x, right? Then we have 20 degrees plus second angle x plus third angle 6x should equal 180 degrees, right? That means 7x equals 180 degrees. That means x equals 180 degrees over 7, right? Which is approximately 22.86 degrees, right? Therefore, in this case, one of the angle is 20 degrees. The other angle is 22.86 degrees. But in this assumption, we assume x is the smallest. And then we solve x is actually 22.86 degrees, right? This is contradictory to the fact that, to the assumption that x is the smallest, because if you compare this angle here and this angle here, apparently 20 degrees is smaller than the x here, right? So x cannot be the smallest one here. Then we found a contradictory. So x cannot be the smallest, right? Let's say this is contradictory with the assumption that x is the smallest. So we can just stop here. There is no solution in the second case. Okay, can you follow me?
Yeah.
Okay, you can have a look at this question and let me know if you're finished.
Okay.
All right, let's see the next one. Okay, question 6. Again, this time we're given a diagram below. The task is to find angle BA, which is here, right? All right, so by first glance, it looks like there are some parallel lines, right? But remember that do not just think that they are parallel unless you can actually prove them, okay? And note here, this angle is 50 degrees. This angle is also 50 degrees. So if you consider these two lines, and this is a transversal line, then this line must be parallel to this line, right? Because this angle here and this angle here are, what do we call them?
They're all, I mean, same side, something angles.
First, okay, let me find you a term. You need to remember the term.
Same side corresponding angles.
Corresponding angles, right? Okay, let me find you the term here. Okay, let's check. Okay, here they are called corresponding angles, right?
Yeah.
No same side. Corresponding angles indicates it must be on the same side. Okay, so let's go back to this question. All right, so first of all, you can say because angle A equals angle DFC equals 50 degrees. Therefore, we have line AE parallel to line DF. Right? And if we have two parallel lines and this angle here is 90 degrees, then this angle here must be also 90 degrees, right? Because these two angles are alternate interior angles, right? Therefore, we have angle AEG equals angle EGD equals 90 degrees, right? And this angle here is 90 degrees. And then if we know this angle is 60 degrees, this angle is 90 degrees, then this angle must be 180 degrees minus the previous two angles, right? Because this angle is a straight angle. Okay, so that'll give us angle BEA. Therefore, angle BEA equals a straight angle 180 degrees minus 60 degrees minus 90 degrees, which is 30 degrees. Okay, have a look at this question and let me know if you finish.
Okay.
Right, let's see the next one. What is the number of degrees of the angle formed by the minute and hour hands of a clock at 11:10 p.m.? Okay, so first of all, let's draw a diagram to illustrate the situation. So suppose we have a clock here. And this is 12, right? 1, 2, 3, 4, 11. Let's suppose 11 is here. And first of all, okay, first of all, where is a minute hand at 11:10?
At 2.
At 2 here, right? This is a minute hand. So it must be exactly pointing to number 2 here. And how about the hour hand? Where is hour
11.
hand? Here?
11.
You mean 11 exactly? Or somewhere
A little in
past
front.
11, a little past 11, right? Yes, it should be somewhere past 11 because it's not 11 It's not 11 o'clock, but 10 past 11. If 10 past 11, that means the hour hand somewhere pointing a little past number 11 here. Okay, the task is to find the number of degrees here, right? Okay, so this angle actually has two parts. It's the sum of this angle here and this angle here, right? And apparently, let's call this angle alpha and this angle beta. And apparently, alpha is not very difficult to find, right? Can you calculate alpha?
It's
So note here, how many marks do we have on the clock?
12.
We have 12, right? And it covers 2, right? 2 of the marks here. Understand?
Yeah. Yeah.
So 2 out of 12 times a revolution, which is 360 degrees, right?
Yeah.
So alpha is easy to calculate, which is just 60 degrees. And as long as we can find beta, we can then find the number of degrees of the angle formed by the minute and hour hands. So how do we find angle beta here? Okay, so if we consider the hour hand, it travels all the way around the clock in 12 hours, right? One round is 12 hours. So it travels at a rate of 1 out of 12 times 360 degrees equals 30 degrees per hour, right? You follow me?
Yeah.
And since it will be pointing at 12 o'clock, at 12 o'clock, at 12, sorry, since it will be pointing at 12 o'clock, and it will travel 5 out of 6 hour times 30 degrees per hour, which is 25 degrees, right?
Yeah.
This is actually beta. You follow me?
Yeah.
Because, you know, when the minute hand travels all the way here, that's actually 5-6 hour, right? 5-6 hour times 30 degrees per hour, which gives us 25 degrees. So that's our beta. Therefore, okay, let's call it AOB. Therefore, angle AOB should equal the sum of alpha and beta, which is 60 degrees plus 25 degrees, which is 85 degrees. You follow me?
Yeah.
Okay. Please have a look at this question and let me know if you finish.
Okay.
All right, so let's have a look at the next one. The angles of a triangle are in arithmetic progression. If one of the angles is 100 degrees, what are the measures of the other two angles? So in case you don't know the definition of arithmetic progression, there is a hint. A arithmetic progression is a sequence of numbers in which the difference between each term and its preceding term is always the same. For example, 10, 20, 30. This is a arithmetic progression, right? Because 20 minus 10 equals 10. Then 30 minus 20 is also 10, right? And another example is, for example, 15, 40, and 65. This is also a arithmetic progression or arithmetic sequence. Why? Because 40 minus 15 is 25, right? Then 65 minus 40 is also 25. Now, do you understand what is a arithmetic progression?
Yeah.
Okay. All right, so basically in the triangle, we have three angles that can form a arithmetic progression. So let's suppose we can let us suppose the middle angle is x degrees, or as measure x, right? If the middle angle is x, then we can say the smaller angle is x minus, let's say, k. This is possible, right? Then we know the larger angle is, so if the angle in the middle is x, smaller angle is x minus k. Can you guess what is the larger angle? What is the measure of the larger angle?
X plus K.
X plus k, right? Because the three triangles can form a arithmetic progression. So the larger angle must be x plus k. All right, and do not forget, we are discussing a question in a triangle. Therefore, in this triangle, so what property do we have? The sum of these three angles must be 180 degrees, right? That means x minus k plus middle angle x plus x plus k largest angle. Sum of these three angles should equal 180 degrees because we are in a triangle. Okay, this actually gives us k canceled with this k here, right? You follow me?
Yeah.
So this actually gives us 3x equals 180 degrees, which gives us x is 60 degrees. Understand?
Yeah.
Okay, therefore the angle in the middle is 60 degrees. And we also know that one of the angle is 100 degrees. Apparently 100 degrees should be the largest angle, right? And apparently this is possible to find the smallest angle. Therefore, the smallest angle is 180 degrees minus 60 degrees minus 100 degrees, which is 20 degrees, right? Therefore, the three angles, the measures of the three angles are 20 degrees, 60 degrees, and 100 degrees. And then we can double check, are they forming a arithmetic progression? 20, 60, the difference 60, the difference is 40, right? 160, the difference is also 40 degrees. So that's in accordance with the given information. 3 angles here form a arithmetic progression. Okay, please have a look at this question and let me know if you're finished.
Okay.
All right, let's have a look at the next one. Okay, is it possible? It is possible for the interior angles of a triangle to be in the ratio 1 to 2 to 6. But is it possible for the exterior angles of a triangle to be in the ratio 1 to 2 to 6? Prove your answer. Okay, so for a arbitrary triangle, we already know that the sum of the 3 interior angles are 180 degrees, right? And also we have proved actually the sum of the 3 exterior angles in the triangle is how many? You still remember that?
360.
360, right? We have already proved this in our previous assignment. So please remember this result as a theorem. You can use this theorem in your future solutions. So the sum of the exterior angles is 360 degrees. Then let's assume the 3 exterior angles are 1K, 2K, and 6K. Because we know the ratio is 1 to 2 to 6, right? So we can just let the 3 exterior angles be 1K, 2K, and 6K. Or you can omit 1 here. Then we know that K plus 2K plus 6K, this is the sum of the 3 exterior angles, right? And we have already know that sum of the exterior angles in the triangle is 360 degrees. And that's actually gives us 9K equals 360 degrees, right? Then we know K is 40 degrees. Then we know the 3 exterior angles are 40 degrees. Then 2K is 80 degrees. Then 6K is 240 degrees, right? But this angle is not possible, right? Because for any exterior angles, it cannot exceed a straight angle. That means it cannot exceed 180 degrees, right? Let's say a 240 degree exterior angle of a triangle is not possible. Therefore, it is not possible for exterior angles of a triangle to be in the ratio 1 to 2 to 6. Okay, have a look at this question and let me know if you finish.
Okay.
All right, then let's have a look at the next one. Point D is on side PR of triangle PQR such that angle PVQ equals PQZ and angle PQR minus PRQ equals 42 degrees. Okay, if there is no diagram, it's very hard to understand what it is talking about, right? So first of all, it's better to draw a diagram to illustrate this question. So there is a triangle PQR, right? So we can just draw the triangle PQR first. So let's suppose this is a triangle PQR. This is P. Let's say this point is Q. This point here is R. Then point C is on the side PR of PQR. So let's say this is point Z. Then such that PZQ. So we need to connect these 2 points, right? Such that PZQ, which is here, equals PQZ, which is the angle here, right? So basically, these 2 angles are equal. And also, the difference between PQR, which is here, and PRQ, which is angle here, right, is 42 degrees. Then the task is to find angle RQZ. RQZ is here. Okay, this is our target, right? We need to find this angle Q. Okay, so what are the given information? Suppose this angle is theta, then we know this angle here is also theta, right? Can you follow me?
Yeah.
So in order to facilitate our discussion, let's suppose angle PZQ equals theta. Then angle PQZ is also theta, right? And we know that, let's consider this equation. Then angle PQR is, okay, let's mark this angle here, X. Okay, let angle RQZ is X. Okay, again, this is just to facilitate our discussion. You can just leave angle RQZ. That doesn't matter, okay? So let RQZ equals X, then we know that angle PQR is theta plus X, right? You consider this equation here. Angle PQR is theta plus X. So minus angle PRQ. PRQ equals 40 degrees. Then we also know that theta is X plus angle PRQ, right? Because if you consider this triangle here, theta is actually a external angle, right? External angle should equal to the sum of the two remote angle. Therefore, theta should equal x plus angle PRQ. Should equal the sum of these two angles. Can you follow me?
Yeah.
All right. So basically now we have two equations. Let's call this 1 and 2. Equation 1 plus equation 2 will give us okay, let's move theta to the other side. Then equation 1 plus equation 2 will give us theta plus x minus angle PQR. That's the left side, right? And plus x plus angle PRQ equals 40 degrees plus theta, right? And then note here we can cancel a angle PRQ, then cancel a theta to both sides. And this will give us 2x equals 42 degrees, right? Therefore, x should equal 42 over 2, which is 21 degrees. Okay, that solves the value of x. Can you follow me?
Yeah.
Okay, therefore we can make the conclusion. Angle RQZ equals x equals 21 degrees. And this is our final solution. Okay, please have a look at this question and let me know if you finished.
Okay.
Okay, I have uploaded my notes on Google Classroom. You can refer to my notes at the review of this chapter, okay? And there is no more homework for this week. Next week, we'll learn something new in the next chapter, okay? There is no new questions for you to solve, but you need to check my notes and make sure you have remembered all the theorems and axioms we have already introduced. Is that okay?
Okay, thank you. Yeah.
Okay,
Thank
see you
you.
next week.
Bye.
Bye.